In this video, I will be covering the different types of joins that are possible in SQL. As we know, an SQL join clause combines rows from two or more database tables into a single table. It does this by relating columns across these tables using primary key foreign key relationships. A query may contain none, one, or multiple join operations. There are different types of joins that are actually possible in the SQL query language. The first type of join that we have been learning and using so far is known as an inner join, or typically just referred to as a join. In an inner join, what we are attempting to do is selecting records that have matching values in both tables. That is, the primary key of one table is present as a foreign key in the other table. This is a regular inner join. We can have a couple of other types of joins, specifically left join and right joins. In a left join, we are going to get rows from one table that have a primary key present as a foreign key in the other table, in addition to rows from the first table that don't have their primary keys present as foreign keys in the other table. On the other hand, a right join is the converse of a left join. We're going to get rows from the right table. In fact, we're going to get all the rows from the right table in addition to those rows from the left table where there is an overlap based on the primary key foreign key relationship. A full join selects all records that match either left or right tables, including rows that are present in both tables based on the primary key foreign key relationship. Let us take a look at an example of a regular join and then see the result of a left join and a right join. Let us use the Classic Models database. And in the Classic Models database, we have a couple of different tables: customers, employees, offices, order details, orders, payments, product lines, and products. In this case, let us work with the customers and orders table. And let us join the customers and the orders table using a regular join or an inner join. To join these two tables together, one might write a query like this: select star from customers, join orders on customers.customer number, which is the primary key of the customers table, be equal to orders.customer number, which is the foreign key of customer in the orders table. This is a regular inner join, giving us all the rows from the customers table in addition to rows from the orders table where that customer number matches up. And so you see we have 326 rows returned. And the reason we have 326 rows returned is because there are 326 orders, and each order is associated with the customer, giving us 326 rows. And so on the left-hand side over here, you see all customer-related information. And on the right-hand side over here, you see order-related information such as order date, order number, required date, ship date, etc. And you see the customer number associated with that order. Now, one of the queries that one can ask based on this regular inner join is how many orders has each customer placed? One could get that result like this: select the name of the customer and a count of the number of orders they've placed. primary key, foreign key, and so since we want to count for every customer, or count the number of orders for every customer, I shall do a group by customers.customer number. If I run this, I have obviously an error, because obviously this should not be order number over here. This should be customer number as well. And so I get the names of customers and the number of orders they have placed. And so I have 98 rows returned. So I have 98 customers, and a list of 98 customers, and I have counted the number of orders they've placed. And so this is typically what you would get if you used an inner join or a regular join. Now, let me show you what a left join looks like. Now, one might wonder, why is it known as a left join? Well, we need to find some way to distinguish the order in which tables are laid out in a query. The table that comes first, that is used as part of the from clause, is typically considered the table on the left. So if one takes a look at this left join diagram right here, in our query, if we used the statement from customers join orders, the table on the left would be the customers table. The table on the right would be subsequently the orders table. And so, in this case, again, let me write the most general form of the query, which is select star from customers. Now, for a left join, instead of just typing a join, you would specify left before that. Again, this is not very hard. Just type a left before the join. Left join orders on customers.customer number is equal to orders.customer number. Now, before I execute the statement, I want y'all to remember that the regular join version of this returned to me 326 rows. If you go down and run the left join version of this, I'm not going to get 326 rows, I am going to get 350 rows. So the left join gave me about 24 more rows of data returned. How did I have 24 more rows of data? Let me explain where these 24 rows come from using these diagrams. In the inner join, the left table was the customers table and the right table was the orders table. In the regular join, the primary key of one table was present in the other table as a foreign key. So the primary key of customers, customer number, was present in the orders table as a foreign key. And so the inner join gave me the shaded portion of the inner join, which is what I got with the regular join, which is the customers that placed orders. What the left join is giving me is, in addition to the customers that have placed orders, it is giving me 24 more rows, and those 24 more rows are those rows in the customers table, that is customers who have not placed orders. I'm getting that result as well. And so the left join is going to give me more data than just an inner join or a regular join. Subsequently, I see 350 rows returned. Now, if I scroll through these lists of customers, you will find there are some rows in which order number has null values. And what these are is wherever there is a null value for an order number, and remember, order number is the primary key of the orders table. It should not be null. But if it's null, that means that row, that customer has never placed an order. So those customers have not placed orders, and so they don't have values. They don't have that primary key, does not exist as a value, as a foreign key in the orders table, and so they have no order numbers associated with them. Subsequently, if we took the same query, select customer name, comma, count of order number from customers, join orders on customers.customer number is equal to orders.customer number group by customers.customer number. Remember, the last time, if we just did a regular join, I got 98 rows returned, 98 customers, and the number of orders placed by those customers. If I do a left join on that same query and run a count, I will get 122 customers, and some of these customers are going to have 0 counts for order numbers. So they have never placed an order. And so what the left join gives me is, in addition to customers who have placed orders, it is giving me customers who have not placed orders, or the part that where the primary key does not exist as a foreign key in the orders table. The right join is basically the inverse of the left join. So if you flip up, um, if you want orders that have not been placed by any customers, which really doesn't make sense because every order needs to be placed by a customer, you would have a right join. One instance of a right join that you might consider writing yourselves is, think about joining order details and products. One might consider joining the order details and the products table using a right join, where the products table comes after the order details table, and so the products table will be on the right. And so what that would give you the product that has not been ever ordered. Consider writing this as practice. This briefly discusses the difference between the inner join, the left join, and the right join. Subsequent slides actually go through this in terms of the syntax and examples. We have just discussed some examples using the classic models database. There is no outer join that is actually available to us. We can't just write outer join in MySQL. To get the result of an outer join, however, one can actually use the union clause. We can't actually write a full join, but we can use a union of a left join and a right join to get the result of an outer join. There is some practice present at the end of the join portion of the slide deck. If you all have any questions about these practice questions, please let me know.